Thanks everybody for being here. Today we'll be talking about how we're building the Ethereum of oracles at SEDA. And before we dive into that, I wanted to take you guys through sort of like the era or the ages of crypto middleware and infrastructure. So it all started in the age of Bitcoin. And this is the era of peace. There was just like users interacting with one network for the most part through wallets that were connected to RPCs, to the Bitcoin chain. And Bitcoin was just like this monolithic application-specific network that had the only goal of essentially accounting. Throughout this era, there were some competitors that came to market, but most of them were just incremental improvements or application-specific chains that were a bit early. Then we entered the age of the monolith. We had Ethereum join to the party. And outside of just having one wallet or one set of wallets or infrastructure to interact with Bitcoin, a second set came to life to interact with Ethereum. And other than that, there was a new need for infrastructure because Ethereum was not only a blockchain that didn't just do accounting, it's also a platform to build application upon. And these applications, very early on, noticed that because they didn't have access to any data outside of their blockchain's execution environment, they were heavily limited in the sort of like use cases that they were able to power. So this is where some middleware infrastructure, such as oracles, came into play. And at this time, there was not really interoperability because there was just like Bitcoin and ETH for the most part. So if you wanted to swap currencies or swap chains, you did that through a centralized exchange. There are some other chains that launched around the same time with similar functionality to ETH. But at this stage, I don't think they're relevant enough to mention anymore, for the most part. Then we entered the age of fragmentation. And I think we are about in the final stages of this era right now. To visualize this is we have like a bunch of blockchains, right, in the beginning, and you're seeing that the middleware is not completely reusable. There's not enough standards. So you're seeing that middleware that was built for Ethereum originally, such as oracles, need to redeploy their entire infrastructure. It doesn't scale well to all these different chains. And at this stage, what you're seeing is that some of the middleware is actually starting to act as kingmakers. If you can get some of the like great middleware providers to launch on your chain, that is like a huge selling point. And I don't think that's necessarily what our industry was built around. Yeah. This is now, I mean, a few months ago, even. So imagine trying to serve all of these networks with sort of like the previous iteration of middleware and infrastructure that we saw. That's not working very well. There's like huge wait times, huge sort of like fees that you're paying or contracts that you're signing with these middleware companies in order for them to launch to your network. So it's time for middleware to catch up. At SEDA, we believe that we're now about to enter the age of hyper-specialization. We are going to see a bunch of hyper-specialized networks spin up. And these networks are going to do one thing really, really well. And through seamless interoperability, we'll be able to create an experience that's cheaper than what you're seeing with a bunch of the monolithic chains that are out there today, because you have like specialized networks doing just the thing that they're designed to do. And yeah, as interoperability gets better, that will be like more realistic. So I think we're like right between the age of fragmentation and specialization. Some of the things to look out for right now are like chain abstraction and intents that are really like going to be powering this stuff. So for SEDA, entering this age of hyper-specialization, we wanted to do the following. we had the following design goals, kind of. So we wanted it to be horizontally scalable. That means that new chains launching and wanting to interact with our network should not add necessarily more load or integration times. The second point is modularity, which is kind of like, I'd say it's like permissionless accessibility. We want new blockchains, new smart contract chains, new rollups to be able to plug into our infrastructure from day one and have access to some of the core features that are necessary for sort of like having a successful ecosystem, right? So if you're building an ecosystem, there is three things you want. You want developers, you want liquidity, and you want users. And if you don't have, it's sort of like a chicken egg coop problem or something, you know? Like you kind of need all three, and then you need to have like this network effect. And in order to do that, there's like a base level of infrastructure that you need. And as there's new chains launching every day, and that's only going to accelerate over the next few years, you need to have permissionless infrastructure to, basically be able to plug in and get sort of like this base infrastructural necessities, such as like interoperability, price feeds, etc. Very much leaning onto that as well is the programmable part. The fact that SEDA does not dictate what feeds you have access to. You can actually launch your own feed on our network. So if there's like some long tail asset that's not supported day one, you can essentially deploy what we call a program to the SEDA chain that dictates how data has to be queried. I'll dive into that in a sec. So what does this infrastructure look like? A little bit intimidating. It's quite simple. You have requests for data, flows down, data flows up. And we'll dive a little bit deeper into how this works exactly. But the key is that we have the SEDA chain, which is a checkpointing and settlement layer. This is where sort of like a single source of truth where people stake and slashing happens in case of misbehavior. Then we have the overlay network, which is a MPC layer, so a multi-party computation network that does the query and compute of the actual feeds, the data feeds. And then on top of that, we have the data providers, which is sort of like the supply side of data. And these data providers can be anything. It can be price data to power price feeds and DeFi. It can be RPC data providers to provide interoperability or execution proofs for solver networks. It can be LLMs to create agentic smart contracts that can interact and own essentially rights to smart contracts, or DeFi data providers for like, I don't know, funny, like long tail finance applications. And then on top of that, you have like the solver relays. The solver relays is the distribution mechanism. So like I said before, SEDA chain is the single source of truth. But how do you, from there, bridge that data over to the actually consumer chains? And that's what the solver network is there for. Let's take a little bit of a closer look and like how this would work if I would want to query a new price feed. So what I would do as a deployer of a new feed is I would deploy what we call a program to the network. And the program is essentially a WASM binary that dictates, it's like a set of instructions that dictates what data is to be queried, from where, and then how that should be computed into a final outcome. So you deploy this to the SEDA chain, and in return, you get a ID referencing your program. Then anybody that actually wants this program to be executed by the SEDA chain references this program in a transaction to the SEDA chain. The SEDA chain then uses VRFs to select a secret random committee of overlay nodes, MPC nodes, that are then selected to actually perform the query and computation. We'll zoom in on like the overlay node right now. So the overlay node is essentially a wrapper around a WASM VM, and it just blindly sort of like executes the binary. So it just does like, in this example, it like queries 4 sources and takes the median price. It then reports the final outcome that comes out of the computation back to the SEDA chain, where it's then batched, Merkleized, and signed by the validator set. And then this is where the solver relays come in. Because of the way we use, because of like our cryptographic accumulation on the SEDA chain, you'll have a signature that can be verified on any destination chain by any smart contract, which allows you to prove data state. So any solver can then come and essentially bridge the data from SEDA to a destination chain of their need. So there's like sort of like 3 triggers that I'd say would trigger a solver to do this. The first one is that it's a solver run by a project. So let's say I run a lending protocol on a rollup I deployed, and I want the price to be updated every minute. What I would do is I would run my own solver that basically just pings the SEDA chain every minute and updates it on my destination chain. The second reason is because maybe there is MEV exposed on the destination chain, right? So there's a liquidation that can be executed on a lending rollup. So me as a solver decides to bridge the data over and liquidate the position because it's profitable for me. And then the third one is because there is a bounty posted on the destination chain. It's sort of similar to the second point of MEV, but it's not, it's like just a bounty being posted on the destination chain, and I can claim that bounty by bridging data over in case that the application does not want to be responsible for the delivery of the data. So to run the point sort of home of why I sort of like make this comparison between SEDA and Ethereum is that you can describe Ethereum as enabling anyone to deploy smart contract, which then any other person or themselves can interact with, or any smart contract, right? SEDA enables anyone to deploy data feeds, which can be interacted on by any smart contract on any chain. And it's sort of like how Bitcoin was sort of the application-specific blockchain that just did like one thing that it was programmed to do. That's also what you're seeing with a lot of the Oracle products that are out there today. It's like they're just doing price feeds, they're just doing bridging, where we're trying to build a more of a platform that allows people to build permissionless data products on top. That was it. Thank you very much. I'll be out front there if anybody has questions.